let's go ahead and get these things open and see what comes in the box. This one's birth certificate is 857 watts. All right, that's what we gotta beat. 502 came in at 607. Now, even though this is a DSP amplifier, remember, all Q class can be used as a standard amplifier. They have all the regular switches on the end. We're not gonna be using the DSP built into this. We're just gonna hook it up as a regular 2-channel amplifier. So just like in the lab back home, we have power distribution here, feeding off of, well, they have way more power than we do. We have our signal here. We have our inputs and outputs that we can connect up to the amplifier. And of course, then we have the wiring that's gonna go over to the dyno itself. So we have our amplifier all hooked up, and we're gonna go ahead and set up our Amp Dyno.
Our amp's on.
Amp is on.
You're gonna go to DD1 plus, track 12. So we're on track 12. Our gain's set to minimum. Gonna click next. I'm gonna go play, turn it to the distortion LED, starts coming on. There, back off 1. That's volume 48. Click next. Turn the amplifier gain up all the way, which, screwdriver. Go all the way.
Yep, you're up all the way, lights on.
Next, go to track 14. Through track 14, this is your dB overlap. Click next. So it's 20 dB of overlap. Let me know when it says 10.
Keep going. You got 14, 13, 12, 10.
Yep.
Up 1, you're on the border. So you're at 9, you're at 9, 10, 11. Oh, I love this part. There you go, perfect, 10. You got 10.
We're gonna kill the audio there. Click done. Now our gain's set.
So what this has built into it is the DD1 Plus. We've gone ahead and done the setup process. You have to do the setup process every time. It's one of those things that you just don't show because it is kind of boring. Because I've never seen it, I thought you guys might want to see it. Now are we ready to go?
Yep.
All right, first test we're going to do is a certified test, and we're going to do it at 2 ohm, and we're going to do it at 14.4. Enter, mono.
Ensure the jumper's in place, which it is.
The jumper is in place. Next.
Okay, so click that until you're at 2 ohms.
Okay,
click enter.
Enter.
All right, so it says go to track 4. Track 4 is the 40 hertz tone. Track 9 is the 1K tone.
All right, let's run it. All right, so that ran us up, gave us our max power at 2 ohm at 14.4, which is 646 watts. We're gonna reset and run it at 1 ohm. Wow, so we have 1,045 at the 1 ohm that the amplifier is rated for. So we're gonna go back, and now because this will go down to 0.8, it'll go down to 0.6, it'll go down to half. Let's try 0.8 just for something fun. All right, so we'll cycle this through. Now keep in mind we're still at the 14.4. We'll hit enter, and we'll go ahead and hit start. All right, so boom.
See it protect itself.
Did it protect itself?
Protected itself, but notice it's not blown up.
So for that one, we got 1170. So the amplifier is not made to run at 0.8. It's made to run at 1. I wanted to run it at 0.8, and they were like, yeah, go for it. And the reason why is because the amplifier has protection built into it to prevent it from blowing up. All you have to do is cycle the amplifier, meaning turn remote off, turn remote back on, and the amplifier is good to go again. Naturally, let's get to go it again, but this time let's drop the voltage down, because 14.4 is cool, but most of the time you're in that 13.2, 13.5 range. We can actually dial these things down. We have our voltmeter right here. We're gonna dial down the power, and we're gonna do the test again. So playing with the dials on it, we got it down to 13.27. You know how it is to use one of these things. It's like, so we're close enough. Now we'll go ahead and reset, and we'll do the test again. We'll start like we did last time, and we'll do 2 ohms, but this time it'll be 13.2. We'll hit enter.
Start.
We'll hit start. And we got 546 watts on that run. And we'll cycle through to the 1 ohm load. We'll hit enter and we'll hit start. Now all we have to do is do over 800 watts. And we've done that. We got 870 watts. Now there's no reason for us to repeat the 0.8 ohm load on it because we know it'll do it, but it's gonna go into protect, so that's okay. I just wanted to see what it would do at that 13.2 load, which is a more normal load. Now since we can vary the voltage, personally, I would like to have some fun with it. So just like when we were doing the AP, we took it way below what it's supposed to do. We can do that with this. So I'm thinking, we're here. What do you think? Drop it down to 11.5?
11.5, we can do that.
We can do that. So we're at 11.6, close to 11.5. Let's just, you know what? Let's just go for the big test of 1 ohm and see what this thing will do. Ooh, 651 watts. Did it go into protection?
No, that's good.
We got good power out of it still. I mean, it's 900 watts, but we're well below what this amplifier should operate at. Because it can, meaning we have buttons and we can press them, and we're gonna put things in the worst case scenario possible. This amplifier should blow up if we do 0.8 at this amount of voltage. I mean, because we're so low below what, I mean, if you've got one, like we said earlier, if you've got this much voltage in your car, you got issues. You got issues that you should not be having amplifiers doing something. But we know that, you know, not everyone pays attention to that stuff. What do you say, 0.8?
Yeah, we can do it.
Let's do 0.8 at 11.6 volts. Ooh, yeah. Because, I mean, after all, everyone wants to see how much power an amplifier can do in the best case scenario. Let's do it in the worst. This is the fun I get to have. Thanks, guys. So we'll cycle through to 0.8. Hit enter. Are you ready?
Yeah.
Wow, look at that. We got 726 watts out of it. Is it in protect?
It's not in protection. We're in.
It totally handled it?
Yeah.
All right, let's think about it. It's kind of odd because it went in protection when we ran that before at a higher voltage.
This is an unregulated amplifier though.
So tell me, Mr.
Do you want to know
Engineer.
why? The protection that you're seeing when you're at a legal load is overcurrent protection.
Okay.
Which, how do you get current? Current is
Ah.
a function of impedance and voltage,
I
right?
gotcha.
So as the voltage lowers, yes, then you don't hit overcurrent protection. Overcurrent protection on this amplifier is set at like 1200 and whatever watts, little
Okay.
over what you saw
Right.
that you got. And if you go over that, then yes, the amplifier protects itself because you're getting close to the FET output.
So we didn't do
section.
that.
No, so you didn't
So we
do
didn't
that.
have to
because
worry
you didn't have
about it.
voltage, so yeah,
Oh.
so no protection.
So this is actually a good thing.
Yeah.
Because in these lower stop-start or just these smaller battery cars, this amplifier, though it won't put out
800
watts,
it'll
it's still
continue
going
to
to
play.
fully function.
The new CX amps, like this one, are
Yeah.
all made to work down to about 8.5 volts before they actually shut off, just because of that.
You guys want to go lower? I think we should go lower. He's saying 8.5 volts. I see a challenge. Let's challenge
for
it. Let's go all the way down. He said 8.5 volts.
Let's see how far our thing will go.
Let's dial it down to 8.5 volts. We are going to keep it at 1 ohm though, because, you know, I want to bring this amp home. Alright, so we've actually been playing with this for a couple minutes, setting it up, and we found out that we actually can't get the dyno down to 8.5 volts. The lowest we can get it is 9.5 volts. Like I said, we're trying to do the opposite test of what most people do here, because this is real world. We're trying to break it. I mean, I'm not gonna lie. They said I could, so I'm gonna try to break it. But we're at 9.5 volts, we're gonna do 1 ohm. So let's get this set up. We have 9.44, let's hit start. And we have 538 watts. I'm assuming it's still fully functional.
Still fully functional. Both the power and protection LEDs are on, but those come on at 10.5 volts just to warn you.
Gotcha.
It doesn't actually shut off till about 8.5 volts.
This is worst case, like you got a dead cell in your battery at 9.5 volts. The amplifier's still running, it's still handling 1 ohm. It's not on fire on the desk here. I call this a pretty positive test. You good? I mean, you want me to break it, I'll break it.
I don't know if you can.
Alright, you know what, let's try 0.8. Why not, right? Okay, let's keep going. Alright, so we're at 0.8, we'll hit enter. Alright, we'll hit start. We got 497 watts out of it that time. There again, look at that, 9.36 volts. So now we've had all kinds of fun with doing the worst case scenario possible. Let's go ahead and bring it back up to 13.5, 13.6, and we're gonna do burst mode at 1 ohm and see what we can get out of this thing. I mean, we can do 14.4, but we know it's gonna do great. Like I said, practical application is at 13.5. All right, we're all set. I'm hitting start. The light stopped blinking and we come in at 11.19 in burst mode at 13.4 at 1 ohm. Yeah. Like all good things, there's certain criteria that I must do in order to have the ability to play with these things. And one of them is, even though I don't want to, because it doesn't really matter to me, but it does matter to somebody, we're going to do a 14.4 test and just see how insanely powerful this little guy actually is. We good? All right, let's do it. So we're back into burst. We're at 1 ohm. We have 14.34 volts. And it's going. It's going. Lights, any more lights? They're gonna keep blinking. We're almost there. Boom, we end up with 1283. Now this is just a little silly because it is an 800 watt amp putting out 1283 at 14.4. But I think what we've demonstrated here is that all the way down to 9.5 volts, well up to 14.4 volts, this amplifier is a monster. And it will take a little bit of power and give you power, lots of wattage. And it'll take a lot of power and continue to give you more wattage. And to me, this is one of the things that I've always wanted to do with an Amp Dyno, is because everyone is always worried about max. Well, this is the real world. Let's do some real world testing. Are you ready to do the Q-Class?
Q-Class amp.
All right, so while we're getting the Q-Class amp wired up, a little bit of history about the Q-Class amplifier. The Q-Class amplifier was actually designed, conceived, and brought out 5 years ago. The technology that's in the new amplifiers that we just tested are a lot better as far as like the power supply and stuff like that. That amplifier, as you can see, it works down to 8.5 volts. That's because of the new stop-start technology and being able to, when the car has to restart, it will actually dip that low so the amplifier can handle that. This is not going to do that. We know that because we've actually installed them in cars with stop-start and we know they shut off. They won't play down that low. How low will they play down to, you think?
10.5 volts or so.
So we know we have a floor there that is the lowest amount of power we can feed into the amplifier. So of course we're going to be doing that. We'll get this guy wired up and we'll do some tests.
A lot of different tires. There's regulated, unregulated, semi-regulated, multi-phase, boost. The Cx800 is a boost.
So I turned on my camera just as Joe's decided and explained to me the difference between power supplies, because there's a ton of different power supplies. And the reason why we were talking about it is because the Q-Class amplifier, it's a high quality amplifier. They say it's 500 watts. It's supposed to always give you 500 watts, not 550 watts, not 600, not 1,000, 500 watts. So it uses what type of power supply?
It's a 3-phase power supply.
That 3-phase power supply is designed around the concept of just that. It's not going to be susceptible to voltage fluctuations because it's not really caring about that. It's caring about putting out one thing, which is
500 watts.
This test, it's a stereo amplifier, so we're gonna do a stereo test. Like I said, when I picked this amplifier, I wanna do a stereo amplifier because no one does those. Why would you want to? And it's not a big amplifier, it's a 2-channel. And what is the 2-channel rating on this at 4 ohm?
4 ohms 125 by 2, 2 ohms 250 by 2.
Did everybody hear that? Let's get started. We've got it all wired up. So for our first test, we're gonna do certified dyno runs just like before. Select our 4 ohm load.
Track 9 is the 1K. We're gonna play track 9.
We got 162 and 161 at 4 ohms at 14.42. So rated power was 125 at 4 ohms. This will do 2 ohm stereo. So naturally, what do we want to run it at?
2 ohm stereo.
Good guess. Let's do that. Start dyno. All right, so we got 269 and 271. So according to the box, we only had to beat 250, and we got 269 and 271. Pretty awesome there. So it's doing its rated power, and we're at 14.38 right now. So we're gonna lower that down to the 13.5, where I would like to see it at, and we'll repeat the test. And we'll select the 2 ohm load. This one's giving us 234 and 236. What did we have the first time at 14.4?
269 and 271.
And what did we have at 13.5?
234 and 236.
So we saw a slight decrease when we lowered the power. However, like I said, this is a different type of power supply. And to answer the question on why it did that, Joe?
So as you can see, you get a slight decrease. Not as much as you saw with like the Cx800 amplifier, the boost power supply. A regulated 3-phase power supply like this, you're gonna see some decrease in power, but it's gonna be minimal, maybe 10%, 15% of actual rated. You run down the power path before you hit your cutoff voltage, right? The whole goal of the amplifier is to try to pull as much current as possible when the voltage drops to make up for it. The drawback to that is in a car with a small alternator, you keep trying to pull more current, right?
Right.
So when you do an amplifier that's like this, that has a 3-phase power supply, you need to make sure you have good wire, good power, everything to get the most out of these type of amplifiers.
Run 4-gauge copper. Wow, that was an ad.
Way to go, Colin.
If you guys hear like beeping noises and strange noises in the background while we're filming this, we're in Joe's install bay, which is inside the compound, but there's forklifts, as you saw when we were walking through where the Ark of the Covenant is stored. Well, they're moving pallets around outside the building right now, or outside of our little cubicle right here. I apologize for any of that noise. Work must be done, and even though we're having a good time playing, those poor guys aren't. So kudos to them for getting the stuff done, but let's get back to it. 10.5 on this is shut off, meaning it can't go any lower than that. It's just gonna shut the amplifier off. But 11 volts should allow us to still play, which is good because they're again a non-stop start vehicle. At start could dip down to 11 volts. If you're operating at a low voltage like that, you have other issues, you need to have those fixed. We're gonna select 2 ohms for this test. We're gonna play track 9. We're at 10.97 volts, so we'll hit go. We got 147 and 149. So I'm guessing at that point we really kind of ticked off that amplifier.
A little bit, yeah, you're right at the edge.
One of the things that should be the takeaway here is that we have an 800 watt amp that was doing stellar numbers and going crazy. And it had what you call a boost type power supply.
Yep.
This has a regulated power supply. So there's 2 totally different power supplies and they're acting 2 totally different ways. One of the reasons that I was excited about doing this test is because I was nice enough to have an engineer in the room that can explain to us why these things are doing these things. Because if we're just relying on numbers alone, this amplifier is acting the way it's supposed to act. It's doing what it's designed to do. It's trying to put out the power that it's supposed to be putting out. Now, if we had a clamp on there, what we would have seen is the amperage draw would have went up a lot. Because what it's trying to do is consume more power to put out that power that it said it's supposed to do. Whereas the other amplifier with its boost power supply is just like, it doesn't care. It's like, cool, man. Woohoo, let's make power. Pretty much, right?
Pretty much, yeah.
Yeah. Do you have something you want to say?
Like a million things, but okay. There are advantages and disadvantages to every topology. There's not a perfect topology out there, right? Boosts and power supplies are great for sub amps, and they're very lenient on the install. Meaning the install might not have the best power, might not have the best ground, might have a small battery. They're still going to continue to play. They might not just make the power.
Which we saw in the test.
Which you saw in the test on the Cx8. Regulated amplifiers will always try to maintain as much power as they can by drawing more current. We say regulated and everybody thinks instantly is only going to make the exact same power all the time, and that's not true because of physics,
the test
right?
just showed.
Yeah,
Yes.
Physics won't allow it. So you're going to try to pull as much current as you literally can across your output devices and your power supply to a point. And then once you get past a point, it still sags, right? You can't stop it. But in general, so if you were running this amp between 12.6 and 14.4, you're going to see pretty much 200 to 260 watts all the time.
Which we did.
But if you drop down to almost shut off, the power supply can no longer correct for the poor voltage.
Which is what we just saw there. It's like, this is all you're getting.
Yeah, it's all you're going to get. We can't do any more, right? If we wanted to be really, we used to make regulated amps that were really black and white, which meant once they couldn't pull enough current, they just shut off. Well, of course, to a consumer, then that's very not a good experience, right?
Right.
Because my amplifier shut off. Well, there was a reason. You didn't have enough power going to it, but it's a bad experience for the consumer. So regulated power supplies nowadays are what we call semi-regulated. They're regulated to a point, and then they give up, right? And then they just make what they make. Copper clad aluminum wire, small batteries, bad grounds. These things are really important when it comes to actually really making power.
So the better amplifier you have, the more important it is to have better power wire and a better charging system just to make those things function.
Yes.
Moral to the story.
And always read the resistance to ground when you hook up a ground. Make sure it's good.
So I hope you guys enjoyed us doing a little bit of fun Amp Dyno testing while we're here. And I hope you learned something. I mean, that was really cool. We got to test 2 amplifiers you might not normally see get Amp Dynoed. Well, on to the next thing.